Okay, so let's put some of this stuff together and give some examples, and then you guys will have some time to work on the homework. So now we come to things that look like this, say -3 to 1. And I'm going to have to modify slightly what I said before about area because, well, you'll see. I do the exact same thing if I was given this. I should think area. I should say, well, I want to take y equals x, and I want to say x equals -3 to 1, because those are the bounds. So now I'm over here, -3. 1. I still draw y equals x. That's my slanted line. Y equals x. But if I was to start at -3, now I'm down below. If I end at 1, at least I am above. So if we try and use the reasoning from the very first example where I talk about going from home to work and back, it turns out that the idea is all of the area above is like accumulating in my favor. Everything is below is taking away from it. So to be more precise, when we say the area, this will be called the signed area. It will be the area above, considered as positive, added to the area below, which is considered negative. So basically top area, and then I would take away the bottom area. And I don't think it's too surprising if the picture is anywhere near that the area on the top is a lot less than the area on the bottom. So the answer that I should get for this overall is negative, because I'm going to take the top area and subtract the bottom area off. So the top area up here, again, y equals x, this should be 1. So it's 1 by 1 triangle, so 1/2 base times height. That area is 1/2, and I'm going to consider that as my plus. Area down below here, so this is -3. It's a 3 by 3, so my area there will be 1/2 3 times 3, so that's 9/2. But I'm going to consider that to be negative. So when I put it together, this definite integral, whoops, that's a 1, is the signed area 1/2, which is the plus, but I take away the area that's below, and I'll have -8/2, or yeah, -8/2, which is -4. So fancy word there, signed area. And that's really it. You just figure out what the area is above, you figure out what the area is below, you subtract, and that'll be the answer to my definite integral. I don't have to know anything else fancy besides subtracting two areas. So how can we do this application given specific function? So this is example 5.2.1, where back to velocity. We're given velocity, and there's some questions that are asked about it. So let's see. So the velocity is -32t plus 48. Suppose that you're throwing it up and down. So when we go up, it'll be a positive velocity. When we come down, it'll be a negative velocity. And the object is going to go straight up and then stop because of acceleration pulling down from gravity, and then it's going to come down, and then it's going to hit the ground. So the questions are, what's the initial velocity of the object? Well, if this is the velocity function, 32t plus 48, that when t is 0, that's the initial time. So if we plug in t equals 0 into my function, I will get the velocity at 0, which is 48. And that's exactly what's worked out. So sort of part one here is not too difficult. Time 0, plug it in, we get 48 feet per second. Now, the other one, so usually this is pretty, physics class that's asked, how high does it go? And then maybe what is its height at a particular time? I stop the stopwatch, how high is it above the ground? So the maximum height of the object. Let's try and do that only from looking at the graph. So minus 32t plus 48. So v is, oops, hit the button. Sorry. V of t is minus 32t plus 48. So if I was to draw that graph, then I could plot some points and realize that it is a line at the beginning. I'm at 48. And because this is negative, then the object is going to come down. And I don't know where to stop, so we'll just say that it's going to do that. We can figure out more of that later. So some questions are things like, where does it cross? And what does that crossing mean? So what value of t would cause that to be 0? You can hop in on that. You want to take a shot at that? We want v of t to be equal to 0.
So 1.5.
Okay, good, right. So minus 32t plus 48 is 0. So I can bring the 48, however you want to do it, you can bring the 48 to the other side. Divide, I get 48 over 32. So that's 3/2. So right there, that's 3/2. And if the velocity is 0, what does that mean?
If the velocity is 0, then it reaches its maximum height.
Right. But in general, what is it? I mean, what does velocity equals 0 mean?
The object's not moving.
Right. So the object is not moving because that's what velocity means, being 0. So at this point, velocity is 0, but exactly what you said was that because we're throwing this up, that means when it's not moving, that means it stops. And therefore, after that point, it has to come back down. So this right here is the time at max height. Now, what is the actual max height? Well, it's the area under that curve there. So just like we said before, basically what we said before, but the distance is equal to the area under the velocity curve. So that's the time of the max height. The actual max height will be the definite integral from 0 to 3/2 of my minus 32t plus 48. And in this case, this is where the terminology sort of kicks in, is that I don't write dx because there are no x's. I would write dt, kind of a reminder that the variable here is not x, that it's equal to t. So without doing any fancy calculus stuff, I just want to find the area of that, and well, it's a triangle. So it's 1/2 the base of the height. I'm running a little bit out of room, so I can probably stick it in. So that's 3 times 48 over 4. 48 over 4 is 12, so times 3. I did it right, that's 36. 36. Because area under velocity curve means height. That's that part. And I think the other one is, what is the height of the object when t is 2? So what we need to do is we need to redo this. I'll reproduce that. T equals 2. Well, maybe we can do it here. There's t equals 2. So if I want to know the height, then I have to go all the way from the beginning over to 2. And I want to find the area underneath. Problem is I've got a positive area here, but I've got a negative area down here. And that makes sense because from 0 to 1.5 seconds, it's going up. And then after that, it starts to go down. If I want height, then I have to come down off of this negative height. So squeeze it in, but I don't want to make a whole nother slide here that the height at t equals 2, the height is going to be, again, the area, except anything above is considered positive, anything below is considered negative. So the area above, I already know. That's 36. 36. What's the area below? Well, it's a triangle. So what is this distance here? From 3/2 to 2, that's 1/2. Now maybe a little bit trickier. What's that distance there? So we need to know what the velocity is when t is 2. So if I plug in t equals 2, I get negative 64 and then plus 48. So this is down here at negative 16. So my triangle is 1/2 times the base, which is also 1/2, times the height, which is 16. And I know it's negative 16, but we'll deal with one negative at a time. So it's 1/2 times 1/2, which is 1/4, times 16, which is 4, and because it is below, I want to take away. So minus 4, and I'll get 32. So the only thing that's sort of new maybe today is, again, area under velocity curve is height, or distance traveled, and anything that's above is positive, anything below is negative. So those are the sort of main takeaways on that. A lot of the homework problems are like that. The rest are a little bit more abstract. So, for example, if I said, what is this one? What's the definite integral from minus 4 and minus 4 and 4, if I wanted to just calculate that one? Well, in the picture, I would have minus 4 on one side, I would have 4 on the other side for y equals x. And because of the symmetry, this area is positive, this area is negative. You put them together. Any guesses on this one? Yes, 0. Which looks strange. Again, you're like area 0, and it's like, well, it's signed area because I take the top area and I subtract the bottom area. So I get that. Other properties are like this. If you integrate from any number you want to the same number of any function you want, yes, it's like area is base times height, but the base is 0. There is no base because you're not going from like a number to another number. You're going from one number to another. So there's no like width. So that's always equal to 0. If I did an integral from a to b, and I wanted to compare that against an integral from b to a, and this starts to look weird. Then if you reverse the bounds, in order to make it all work out, you always put a negative in front. So if I go from here to here, or from 4 back to here, in order to make the algebra work out, they reverse signs. The other thing is this: if I do an integral, a definite integral from a to b, that's an area from a to b. Then if I do another definite integral from b to c of the same function, then it's the area from a to b plus the area from b to c. So why did I even stop at b? I don't need to. I can put them together as one definite integral from A to C. So that's like a summation of areas formula where you can combine that all into one. Two more, and that, I think probably I'll let you guys work on the homework because it's better to just get in there and get trying. If I took a number, and the book likes to do this, K, and I go from A to B with some function, then all that does is it multiplies this area times whatever that number is. The fancy thing is, instead of multiplying the area times this number, I could have gone back and just multiplied the original function and then found the area of that. So this is a constant multiple rule for definite integrals. Just like with the derivative, if you have a number inside the derivative, you can just pull it out and multiply at the end instead of multiplying at the beginning. And sometimes that's kind of nice. And then the same thing, if I had the integral from A to B of a function and found the area for one function, and now I add the area for another function, then instead of doing that, what I could have done is I could have taken the function, added, sorry, I got to move this real quick. Added my other function on, then did the area for that. And those last two, I think, will take a little bit of time to figure out why would you ever want to do those. But you'll see as we start moving through the chapter a little bit more that all of these will be things that will be pretty useful as you go through it. So that's velocity, that's these properties, what are called signed areas. And so we covered all of those sorts of things there. And I think that, maybe the last thing here is if you were to just look at this picture here, and I asked you, what is the area what is the signed area, or what is the definite integral? You should at least be able to say the whole answer is negative, because the area below is going to take away more than the area up above. So everything from A to B is positive, everything from B to C is negative, and if you go from A to C, you'll take the top and subtract the bottom, and because the bottom is bigger, you should get a negative answer overall. So hopefully you can look at these things and go, well, that one's going to be a positive answer, that's going to be a negative answer. That one is bigger, that one is smaller. So without knowing any of the functions, just making these comparative things. So there's an example for that. And then, it leads off with, well, what happens if it's a parabola? How do you deal with that? I'm not going to talk about that right now. We will very soon. So I think that's probably a good place to stop for today. Give you guys, half an hour of class time, or actually a little bit more than that, to work through this stuff. If you have questions, sort of maybe toward the end of the time, I'll be around, and you can just ping me again on email. We can hop back on Zoom. But otherwise, I think we've gone through enough stuff to complete the homework for tomorrow. So, thanks for your patience. I know it's kind of a long day. It's summer school, so pack it all in. And I can hang around for a few minutes if you have questions, but otherwise you guys can peel out and get on with your day. So,
Thank you.
all right.
Thank you.
Thank you.
Okay.
you, sir.
Thank you.
Holding strong.